Hi, Algebra 2. In Chapter 5, Lesson 5 here, we're going to be working with rational equations. And the first thing you want to do when you work with rational equations is to look for ways to clear the fractions. This is going to get rid of the denominator for you, so you don't have to worry about it anymore. So for example, in this equation I've written at the bottom, if I multiply each term here by 8t, that is going to get rid of my fractions. In the first term, those 8's are gone, so I'm just left with t. In the second term, those t's are gone, so I'm going to be left with 16. And then in the last term, the 8t's are gone, so I'm just left with 17. So I end up with this equation, t plus 16 equals 17, which is going to be easier to solve. In this problem here, I'm not actually going to get a common denominator. I'm going to notice that if I multiply every single term by x, I'm actually going to get rid of this denominator, which is going to make it easier to solve. So I'm going to multiply every single term by x, and I'll end up with x squared minus 18 equals 3x. And that happens because right here, these x's would cancel out. So now I notice that I'm going to have an x squared term and I have an x term. I'm thinking quadratics, and I remember that to solve quadratics, we need to get this equal to 0. So I subtract 3x from both sides. I get x squared minus 3x minus 18 equals 0. And going back to quadratics, I'm going to solve this by factoring. Now that I solve this, I have x minus 6 times x plus 3 equals 0. So I know that x is going to be 6, or x can be negative 3. Now with these, because we can't divide by 0, we always need to look back. It looks like x could be either 6 or negative 3. We're not going to be dividing by 0 if that's the case. And so those are our two solutions. In this example, I'm going to multiply every single term by 3x because that'll get rid of both of these denominators. So when I do that, my 3's cancel there, so I'm left with 10x equals, my x's cancel here, so I'm left with 12, and then this last term is going to be 6x. I finish solving this just like a regular equation. I get x to be 3, and when I look back, that is a possibility because that would not cause me to divide by 0. With rational equations, we do need to be careful of extraneous solutions. Basically, a solution you get that when you look back at the original equation is not possible because we can't divide by 0. So the big thing here is to always check your solutions with the original equation to make sure you're not dividing by 0. In this equation here, I already have common denominators, and so I know that to make these two things equal, well, the numerators would have to be equal. So really what I'm looking at is just 5x equals 3x plus 4. So when I solve that equation, I end up with x equals 2. Now I have to look back. Is it possible for x to be 2? And no, it is not, because that would make the denominator equal to 0. So this solution does not work, and so there's really no solutions to this equation. I've rewritten this equation showing that I'm multiplying each term by 2 times x minus 8, and that's because that's going to help me clear these fractions. So the x minus 8's are gone in the first one, the second term the 2's are gone, and in the last term the x minus 8's are gone. So I've rewritten what I had left and then simplified it, and now I can see this is going to be a quadratic. I'm going to work on solving that. I've combined like terms and set my equation equal to 0 here, and I can see again that we have a quadratic, so I'm going to factor to solve this. I got my answers of x equals 8 and x equals negative 4. I look back at my original equation and I notice that 8 is not going to work because it's going to cause us to be dividing by 0. So that is an extraneous solution. That one is not going to work. Our only solution is x equals negative 4. Here I factored the denominator, and that shows me what I'm going to multiply both sides by, x plus 4 times x minus 4. And when I do that, that helps me simplify some of my factors. So now I don't have any denominators left, and I have 16 equals 2 times x plus 4. I end up here with a solution of x equals 4, and I look back at my original, and I notice that x cannot be 4 because that makes the denominator equal to 0. And so I end up here with no solutions. Here I'm multiplying every term by 6 times x minus 1. That is our least common denominator, and it's going to help us simplify. So I get rid of my fractions and they are now cleared. And now I just have 6 equals 6x plus x times x minus 1. Here I've gotten my equation equal to 0 by subtracting 6 from both sides, and I multiplied out with the distributive property here and combine like terms. So now I have this quadratic, and I can solve it like any other quadratic with factoring. I ended up with two possible solutions, x equals -6 and x equals 1. I look back at the original, x cannot be 1 because it makes it equal to 0, so that's not a solution, but x equals -6 is. In this problem here, we have a lot of information with the kayaker traveling upstream and downstream in a total of 5 hours. So some things to do to organize our information. First, the total time she travels is going to be the time she goes upstream plus the time she goes downstream. And when she's traveling upstream, her speed is going to be her normal speed, that 2 miles per hour, but she's fighting against the current of the river. So it's going to be minus whatever the current of the river is, and that's what we're trying to find. When she goes downstream, that's going with the river, and so it's going to be her normal speed plus the speed of the river pushing her, plus the current. And the units on these speeds is going to be miles per hour. So we know her total time was 5 hours. Now the time she takes to travel upstream, we know she goes 2 miles at this speed. So we're going to have to do some unit conversions here. So this, her speed, we can convert into every 1 hour. She's going 2 minus c miles, and she travels 2 miles. Plus her downstream, we can take her speed, which we're going to do as hours per mile. So we're just going to flip it 1 hour over 2 plus c miles times, and she did that for 2 miles. So those then cancel, and we're just left with hours. So simplified here, we have 5 hours equals 2 over 2 minus c hours plus 2 over 2 plus c hours. Now we can solve this like a rational equation. I'm multiplying every single term by 2 minus c times 2 plus c, and I'm going to be able to simplify a few terms here. As I've multiplied everything out and combined like terms, I'm left with this. I could solve this like a quadratic, but I'm going to do something a little bit different. I'm going to work to get c by itself, and when I do that, I'm going to divide here by -1. So I have c squared equals positive 12. Now I'm just going to take the square root of both sides. So I get c to be the square root of 12. So that is the speed of the current of the river. Square root of 12 is going to be somewhere between 3 and 4.